So good morning, good afternoon, or good evening. This is the Antrea community meeting, and we are back after a break for the Spring Festival. And so thanks for joining again the meeting. And for today, we have a presentation from Bin and Rochen regarding a multicast policy enforcement. So without, let's not let's go straight into this presentation. So, yeah, I'm Bin Ruochen. I don't know who's going to present, but the floor is yours. Please go ahead.
Okay, I will first to introduce the multicast network policy design, and later Ruchen will have will introduce the metrics for multicast. Let me share the screen. Oh, can you see the conference page?
Yes, we can.
Okay. So far, Antrea has implemented multicast traffic, but there is no network policy for multicast. So all packets will be passed for the port. For security consideration, it is better to support multicast network policy. Here is the pipeline I propose. First, we will have a IGMP table to deal with IGMP query and IGMP report, and later it will deal with multicast egress, and then it deals the multicast traffic and multicast ingress. For the IGMP table, we will define rules to block IGMP query and also IGMP report to specific port, and yeah. And for the egress, we will multicast egress. We will define rules to block or allow the traffic come out from specific port. And for the ingress, we will define rule to allow or drop the traffic to the specific port. Here is the CRD. I want to reuse the existing define for in SMP, but extend with two members in the rule. Here is the multicast address that means the members to store the multicast address I want to use drop or allow, and another member is IGMP. It means whether the traffic is for IGMP traffic or for normal traffic. And here's a sample for the definition. So the first feature is to block IGMP query to pause. Since in our current implementation, Antrea agent will send IGMP query to all ports on the node. And for this condition, if we should block, if we want to block the IGMP query to ports, we need to have some change for the current implementation. First, Antrea agent will create a group for the address, for this address in the IGMP query like this. And then when there is new port created, Antrea agent will add the port to the IGMP query group. While there is a port to be deleted, Antrea agent will remove the port from the IGMP query group. And if there is a rule to block IGMP query to specific port, for example, if we use port selector, which matches app is F1, and then Antrea agent will check the matched pod, and at the same time, Antrea agent will also maintain a list that the pod is using which bucket in the group. Then we will update the bucket. For example, for the pod which matches this label, we checked the pod is using the bucket one, then we will add drop actions on bucket one. And if the rule to block the IGMP query deleted, then we will reset the IGMP rule to the original one. Yeah, this is for the IGMP query to block. This is the rule to block IGMP query. Any questions for this? Okay, and the second is IGMP report from pod. For this condition, normally we Antrea agent has packed in and normal actions in current implementation, but for IGMP v2 and v4, OVS cannot recognize IGMP group address. So to implement the block, we want to implement this feature in Antrea agent. This means for the IGMP protocol, for IGMP protocol, we will check the network depth is sorry. We will check the network source address if it's from the desired IP address, then we will check if it's from the pod, and if yes, we will submit this packet to controller, and then the packet is the agent, and the agent will check if the packet should be blocked. In this condition, Antrea agent will send we will define a query API for agent to check if the packet should be dropped. If yes, Antrea agent will not add the pod to the multicast address group, and it will have some it will calculate the packet dropped by this rule. If yes, if it should not be blocked, then Antrea agent will add the pod to the multicast group. And for the last feature is that to limit a specific pod to send multicast to specific multicast IP addresses, which means that we should block the from both the source and the destination. And for the ingress, we will check the matched pod, and then on the node, we will define several rules to block the traffic, multicast traffic that comes in the matched pod. First, we will define rule to, for example, if we want to block the multicast traffic from this IP address and to 225.1.2.3, and then we have this construction rule, and later we will load this construction to this right, and we will also in this condition we will go to the the table for multicast ingress metric, and in multicast ingress traffic, we will define a rule to drop the packet, and also we can
presentation. Oh.
Sorry. Okay, I will continue.
Yeah, go ahead.
And in this table, we can also calculate the number of packets dropped by this rule. And for multicast egress, it is I think nearly the same. We will define the rule on the node that runs the source pod, and we will also check the source IP address and also destination IP address, and also load the conjunction ID to this rag. And then in egress metric, we also define a rule to drop the traffic. And then we can also calculate the packet dropped by this rule. Yes, this is for the two features for multicast network policy.
Thanks, Bin. And anything else to add regarding the design? Implementation, I don't know. Otherwise, we'll probably check if the community has questions regarding this proposed design.
I do have a quick question or comment on the API design for this, because I know that on the API you said this there are some fields added to the ACMP or AMP ingress or egress rules, but the way I see it, I'm not sure like if the rule would make sense if in a single rule there is actually a normal peer and a multicast peer at the same time. Would it actually make sense? And if not, then maybe we could consider doing something different here. For example, adding a new type of rule, which is ingress multicast rules or egress multicast rules, just to differentiate them from the current rules, so that we have a clear structure on how things are gonna be enforced. I'm not sure if I'm expressing myself clearly here, or at least have we actually considered this alternative?
Okay, I know. In fact, I also have the same concern. Define since there is it's not always the same for multicast rule and the normal rule. I want to why I didn't define new is that I want to reuse the existing, but maybe they are not quite related.
Actually, I was thinking in another way. Could we just use IP block to specify the multicast IP address? Why we need a new field for multicast address?
If do you mean, for example, we just use this IP block other than
right.
the multicast? Yeah, we can use that, but if we use IP block direct, maybe it's not clear for the customer what it means. Maybe customer will define some IP address that is not a multicast address, maybe a normal IP address.
But it's fine, right? They can in one IP block they can have both unicast and multicast IP, right? So if they want to allow both unicast and multicast.
Okay. What I want is to make it maybe simpler to implement to introduce less judgment for the IP address. If we put them together, maybe we need to judge this is if this IP is a multicast address.
So that check is pretty simple, right? I
Yeah.
mean, it's very simple to check it's a multicast or not.
Yes.
And also for IGMP, I probably need to understand that better. If we really want to differentiate IGMP, I kind of feel, I'm just thinking aloud, should we just use a generic mechanism? For example, we can add a new field for IP protocol. And then if you want to allow or disallow IGMP, you can put the protocol value 2, right, for IGMP.
Yeah, we can do this. I want to maybe, I think this is more direct to our chart for the packet.
Yeah, I think the reason I'm proposing some generic way is like if you add new protocols more and more, then you end up with many fields
Yeah.
in this zero definition.
Correct.
So if we try best to reuse the existing fields, so I think if we can do that, we don't need to introduce a new tab, multicast tab for the rule, right? Yang, how do you think?
Yeah, that's what I think. I mean, this is a little bit of personal preference, but from my involvement with the upstream Kubernetes upstream discussions on resources and stuff, it seems that in most cases, if we really wanted a new resource that's essentially built only for multicast type of policy enforcement, then usually what the community would suggest is that we sort of like scratch out an entirely new API, which is simply focused on multicast support, so that we don't have to reuse any sort of like ingress and egress rules and add really weird fields like is IGMP in there, because it's a field that doesn't really make sense if you're defining a regular ACMP and it's sitting there. So it kind of like makes defining other ACMPs a little bit harder, or it's not, at least it makes the work done in validation webhooks a little bit harder, because now you have to invalidate a lot of illegal combinations of applying a couple of fields. So in my opinion, it will be better off to separate this intent as best as we can, so that the ACMP will stay as is, or we can add some new maybe rule sets in the ACMP, but not to reuse the current ingress and egress rules. But that's just my personal preference.
Yang, one question on your comment. Not clear to me if you're advocating for adding a different kind for multicast policies or a different section in Antrea network policies.
I mean, my idea was like, I'm fine if we go with the second, but I would prefer we go with the first. I think that's my point here. Yeah,
I understand. I understand. Yeah, it's better to be clear, because yes. So basically, having a completely different type of object for multicast network policies. Is there any case where this could be a bad user experience? Because I'm just thinking aloud here, because there could be a policy, a security configuration, which we normally could express with a single policy, but now requires us to create two different objects.
Yeah, that's true. That's a really valid concern. But I mean, in that case, something like, you have a single apply to and some egress rules and some multicast egress rules, something like that would be a little bit clearer. But yeah.
But I don't think, honestly, this is a big concern now. Follow me, probably I'm saying something stupid. Normally, an application, let's say the types of traffic sent by an application are completely distinct between unicast and multicast traffic, right? So it's typically like the same application. It probably, if it sends, it needs a configuration for multicast traffic and then another configuration for unicast traffic. So it might actually make sense to have them into distinct objects. Don't know much about multicast, so maybe I'm saying something stupid. In any case, I tend to agree with your statement, Yang, that it might be easier to define such this policy in a new object. And it will also require less, how can I say, less special casing for Antrea network policies, because we don't have to worry about flags and invalid combination of invalid attributes and so on. And so there are comments on the chat. So first, Vicky is correctly suggesting that we need to open up these for public review. So the contents that has been reported here should be available on the Antrea GitHub for allowing the whole community to review. And then there is also a comment from Janjun. He would like to consider something where you have action deny protocol IGMP, and so that later we can support more protocols as well. So Janjun, so basically you're suggesting to consider IGMP another protocol in Antrea network policies instead?
Yeah, I just want to expand my previous comments with this example. If we add a more generic way to define protocols, and it can be like something like this. You have a protocol field in the rule. That can be IGMP, and later it can be ICMP and other protocols we support.
It already has. I mean, we already have a protocol field which can take CCP, UDP, or ICMP.
Right.
So I didn't know that why we would have to need a IGMP flag here. I didn't know the context. So if we can integrate this IGMP protocol into the protocol field, that will be the best case scenario in my opinion.
Yeah, I think the reason, I guess, it's more like this IGMP protocol makes sense only for multicast.
Yeah, but Janjun, I wanted to ask, why do we even need this IGMP flag if we already specify that it's a multicast address?
And
yeah, that was my question. Yeah, go ahead, sorry, Janjun.
Yeah, probably Bing can expand more, but my understanding that we want to separately block IGMP. So for example, maybe
okay.
Yep.
I thought that was a mechanism through which we implement this is by blocking IGMP messages.
Bing, maybe you can clarify. I think we want to say, for example, we allow multicast, but we block IGMP. That's my understanding.
This is purely defined by PM. This is why the first is to define SMP to block IGMP queries and IGMP reports from pod and toward pod.
Actually, I think the requirement is that the user might configure the NP network policy to drop some IGMP packets from the specified pod, or so I mean that maybe we don't drop all IGMP packets, but only the IGMP reports from 1, 2, 3 of ports, but we could allow the IGMP reports from the port 4, 5, and so on.
Yeah, and I think in this way we can block some ports to join specific multicast address. So, for example, the customer are using for the TV show, they only the paid customers can access some resources. Then maybe they can define some multicast address that only specific users or maybe IP addresses can access this multicast, can join this multicast address and receive the TV shows from the sender. Maybe this is a scenario.
Being and the team, I think maybe offline we can discuss about the requirement, whether it makes sense to the multicast use case. So I think it should be an action item to get something clarified, especially about the requirement. But in general, actually I agree with Jianjun. I think if we can do something generic in a generic way, we do need to introduce those specific fields. Otherwise, maybe we have to, we extend our Antrea network policy, but with just unnecessarily. So I think maybe you can just think about how to reuse the fields to see how to support multicast. And if it introduce some complex logics into into the logic, but it can simplify the user face interface. I think it is it is worse for us.
Thanks, Vicky. The only other question that I have is that more from an operational perspective, like now, do you have a POC for this? Do you have a working implementation? Just want to figure out, once this is reviewed by the Antrea community, how far we are then for having a working solution.
Yes, I think you already made some POC code to implement network policy for multicast traffic.
Okay. Yeah, I have some POC, but not code, only for the OpenFlow rule.
I see. So basically, you created code that generates the required OpenFlow rule, and what is missing is like the API changes and all the processing of the Antrea network policies to create these rules. Is that correct?
Yeah.
Okay, and so ideally, if this is put for review, let's say publicly, then this could be a target for Antrea 1.7 or 1.8. What do you think might be the most suitable target?
Okay, I will later update the code on update the doc on Google Doc.
Yeah, you can. I was actually simply asking whether you think this is more an item for Antrea that we can target Antrea 1.7, or that you would like instead, you think it might need more time and therefore should be targeted for Antrea 1.8.
I see.
Yeah, I think the first thing is to finalize the API. Then only with the finalized API, then we can maybe discuss the implementation based on that. So I think you can move the design document to the GitHub or Google Doc and share with the community for more discussion. Then I think at least in entry 1.6, let's finalize the API design.
Okay.
Yes, that's a good idea.
So Ruochen, I think Ruochen also have another part to share with us.
Sure. I will share the screen. I will share the multicast matrix design in the next few minutes, and I have created a GitHub issue for that requirement, and as you can see that we have two sections of multicast metric requirements as I copied from the PRD doc. And sorry, can anyone see my screen?
Yes, we can.
Hello?
Or at least yeah. I can.
Cool. Cool. And we have two sections for the multicast matrix requirements, and one for purport states, and other is per multicast group states. So to show both of the stats, I will introduce two kubectl commands. The first one is get pod multicast stats that shows multicast stats in pod view, and basically this command will implement these four requirements. That is multicast packet job by transmit by pod interface, multicast packet job by receive by the pod interface. Here the transmit and the receive means ingress and egress, and also IGMP packet discarded and accepted. And then all of these requirements are also showed by different network policies. So in the kubectl JSON view, you can see that for each network policy, we also show the stats here, and also this is the aggregate stats for one pod. And we also have another kubectl command called multicast group pod members. In this command, we show the mappings between multicast group and the multicast pods in the whole cluster. So we also have these two requirements that's we don't need to expose these stats in the cluster wide. We only need to show these two in the per node. So I will introduce another kubectl command called multicast stats that shows the inbound and outbound stats for this inbound and outbound multicast stats for that pod. Okay, that's the APIs I want to basically implement. So here, next I will talk these APIs in detail. So there's a so basically for the kubectl command, I want to accumulate the stats from different nodes from entry agent and aggregate them in the entry controller. So I will reuse the struct called node stats summary. That the node stats summary is previously defined and used by implementing level policy stats. So I will add extra field called multicast stats here that contains the multicast stats in that node. So so there is there's a level policy reference here, and also although these fields I think they are self-explanatory for that level policy, and also I will add a field called group join list, and this list is a group of multicast IP address that the pod join, and this field is later used by that command. So also so how do we get these stats? So for first inbound job, outbound job, IGMP allow IGMP job. These stats we can obtain. Sorry, there's something wrong with that. Okay, I will. So there are some stats I defined in the struct. Also, I need to describe how can I get these stats. The IGMP allowed and IGMP job, they are retrieved by processing packaging of IGMP report message. As being described, we do not implement implement blocking or accepting IGMP message by adding OVS flows. We are implemented by using processing of packaging of IGMP report message. So when we are processing IGMP report message during packaging, we can create some data structure to store the stats while processing IGMP report message, and also a function that created by being is that I can created by being that I can use to query if that IGMP report message will be allowed or dropped. So after this, after the process I described, the stat of the IGMP allowed and IGMP dropped can be obtained by the HA agent. And also we need to collect inbound job, outbound job, along with inbound and outbound in the multicast stats. These stats will be created by passing the flows I added in the pipeline. So as you can see in the pipeline, and there's some I have added a table called multicast egress per pod matrix, and also multicast ingress per pod matrix, because we are collecting the stats based on for each pod, and yeah, so you can see in this flow, the network depth is based for each pod in that entry in that node. I create a network depth to match it. So after so when the multicast traffic goes through this pipeline, the traffic will go to this network policy first, and resubmit to the table multicast egress per pod metric I described, and so pre-pod stats will be collected based on passing the flows I added here. So after getting this stats in the HN agent, these stats will report to an entry controller and aggregate them. Finally, we define the public APIs for display these stats through kubectl. And the API group, I think it will be stats entry.io, and these are the API endpoints. Also, I was considering Prometheus integration, and I have checked the discussion in this thread, and I think Prometheus is not suitable for this kind of stats. So I will not plan to integrate it. And that's the end of my presentation. Please ask questions if you have any. Thanks.
Is there any question for Lucian regarding multicast statistics?
Salvatore, I was just pointing out on the chat that this API design may need to change a little bit if the multicast API presented by Bean for network policies is updated to incorporate feedback.
Yes, that's a good point.
Because I think as it is right now, it makes sense, because Bean was proposing to introduce dedicated fields for multicast addresses and IGMP switch in the network policy type. But if we converge to something more generic, I think we also need something more generic here. I'm mostly referring to the part tied to stats for multicast network policies. I think that's item 5 in the list here, 5 and 6. Yeah.
Yes, that's correct. So we can say that perhaps we want to have first a conversation about the APIs for multicast network policies, and then following the outcome of that conversation, the APIs for multicast statistics will be determined. Okay, any other comment, question, curiosity? Okay, it seems that it's all in terms of community questions for today. So thanks a lot to Bean and Luochen for doing this presentation. We look forward to seeing a specification a proposal for multicast network policies on GitHub so that we can finalize the API design and proceed with the implementation. Yes, so if the community doesn't have any other topic to bring up for today, I will probably consider this meeting concluded. Also, because we have just 3 minutes left, so I will just wait for a few seconds in case anyone has any additional topic to bring up.
Oh, we have 13 minutes left.
Oh, that's right. That is right. We have 13 minutes left, actually. Sorry, now I'm used that meetings are 50 minutes long to give time to people to move to the next meeting, but I did forget that the Antrea community meeting is actually an hour long. It's scheduled for an hour. So yeah, we have plenty of time to discuss new topics. So if you have anything to propose, I'll wait for a few seconds before closing the call.
Well, I just wanted to make a quick announcement that the old Antrea APIs, which date back to before the 1.0 release, have been like officially removed, and they won't be present starting in 1.6. So those are the APIs ending in I think it was tenzu.vmware.com, and we replace those APIs by Antrea.io APIs. And so yeah, we no longer serve the previous APIs starting now, and we're able to remove all the mirroring code that was taking care of mirroring old API resources to new API resources for backwards compatibility. So we've been supporting the old APIs for about a year now. So as per the deprecation policy, we can remove them.
Thanks, Antonin. And for developers of the Antrea community, this simply means that in case they are still using these APIs, maybe they will realize that their PRs, the code in their PRs will stop compiling, right? So they just need to rebase and update their code.
Yeah, that's also a big change for users, right? But that's why we supported the old APIs for a year.
That's right.
So it's impossible to upgrade in a non-disruptive fashion, but you have to do an intermediate upgrade. So if you're using Antrea 0.13, first you have to upgrade to 1.0, for example, and then transition your CRs, and then using our mirroring controllers, and then you can upgrade to 1.6.
Yeah, that seems like a reasonable upgrade path. Okay, so anything else for today? All right, so it's all for today. Thanks everyone for attending, and I wish the community a good evening or good night, actually, if you're in the United States, a good day or a good afternoon. So thanks for joining again, and talk to you in 2 weeks' time.